You've seen the front of the clock already, but just in case you were wondering, here's what the back looks like. By now, you're probably pretty familiar with how the clock works, so here's the entire thing in action again. Okay, that's enough. Let's pause it. I would like to direct your attention to these counters now, because not only do they count the time that has passed by, which in this case is 9 minutes and 40 seconds, they also count the number of balls that have passed through the timekeeping. So to read what the counter says, I simply have to add the number of balls in the top counter plus the number of balls in the second counter times 15. So that would just be 10 plus 9 times 15, which is 10 plus 135, which is 145. So the counters tell me that 145 balls have passed through the timekeeping so far. And let's go ahead and check. So this top tank has 87 balls because it's full. The lower tank has 17 balls in its first layer, 17 in the second layer, 1 ball here, and 4 balls here. So that's 17 plus 17 plus 1 plus 4, which is 34 plus 1 plus 4, which is 39. So the bottom tank has 39 balls. 87 plus 39 is 126. 126 plus 9 is 135. 135 plus 10 is 145. So yeah, the number of balls in below the timekeeping matches the number of balls read out in the counter. So I know that this entire thing is called a mechanical ball clock, but I just as well could have called it a mechanical ball counter. By the way, this is really random, but the whole color scheme of the clock reminds me of M&M's, mostly because of the brown. Speaking of colors, you will see that I have brown, black and white, and also silver, and I have red, yellow, green, and blue. But there's also violet, and I won't tell you where on the clock the violet is, but if you look through the video, you'll find it. Also, I have nicknames for all of the, or practically all of the moving parts in the clock. So the primary escapement is Parrot 1, this is Parrot 2. The pauser, I call that the duck. Counter 1 is Crocodile 1, counter 2 is Crocodile 2. This is the whale, because this is the head and that's the tail, and these are the rhinos. One of the most exciting things about this project was being able to discover new things even after I thought I had finished. So for example, with this regulator, if I jam it up, I can cause it to do this weird thing. And with the timekeeper, let me go ahead and remove this first. With the timekeeper, it turns out that I can make the clock run twice as fast by adding another ball right there. So now there's 2 balls on this set of track instead of 1. My idea for this clock actually came to me over a year and a half ago. I was working on another project, and I was wondering about this problem, where I have an input disk that's spinning at a variable rate, so sometimes slowly and sometimes fast. And then I was wondering if there was a mechanism that can take this variable spinning rate and cause an output disk to always spin at a constant rate. Well, while I was thinking about this problem, I realized that I could solve a problem that was similar to it, where this time I have balls entering a mechanism at a variable rate and exiting the mechanism at a constant rate. And what's more, I realized that if the balls are exiting at a constant rate, I could use that to build a clock. Anyways, as you might have guessed by now, the mechanism is basically the timekeeper in the current clock. The input is the rate at which the balls enter the storage, and the output is the rate at which the balls exit the primary escapement. Here's the first blueprint that I have of the clock. If you look in the top right, you can see that it says January 2018, so that was quite a while ago. I didn't really do anything about the clock until March, but in March I started to create blueprints again. But I still hadn't created any prototypes. Prototypes wouldn't come until July. And in fact, I have two of them right here. Well, these are the only two things I printed at that time. Anyways, after that was a long break, and it wasn't until mid to late April of 2019 that I really began to dig into this project. That's when I started to do some of the heavy designing and 3D printing. And of course, there's a lot more blueprints. But the point is, this was one big journey, and it's pretty incredible to think that all of this adventure came from just one idea. Since most of my work happened after April 17, 2019, I think it's fair to say that this project took me a little over 3 months. I noticed that the real struggle during this project was not making parts that worked some of the time, rather it was making parts that worked practically all of the time. As a result, even though I'm technically done with the clock already, I know there are many potential areas of improvement that can make this clock just a little more reliable than before. But despite the flaws, the clock runs pretty reliably, and I'm really happy with how it turned out. Anyways, that's just about all I wanted to say, and I hope you all learned something from it. Now, I'm still pretty new to this whole video editing thing, so if you have any feedback or suggestions, I would love to hear it. And who knows, maybe I'll see you again next time. Bye.